My name is Angel Munoz, and I'm with the IRI, part of the Earth Institute at Columbia University. In this video, I will explain how to compute anomalies for subseasonal to seasonal data available in the IRI Data Library. There are two types of reforecasts in the International Subseasonal to Seasonal, or S2S, database. On-the-fly reforecasts are produced every time a forecast is made available by the producing center. So they use exactly the same model version and correspond to the same date of initialization. Nonetheless, they tend to have just a few ensemble members due to the computational cost involved. On the other hand, fixed reforecasts were computed once by the producing center at some point in the past for a fixed set of dates using a frozen version of the climate model. Thus, they may not exactly coincide with the initialization dates of the forecasts we want to use, but have the advantage of normally having more ensemble members than the on-the-fly reforecasts. So let's compute rainfall anomalies for the on-the-fly reforecasts first, using as an example the ECMWF model, the April 16, 2018 initialization and week 3 as a target. So we can go to the iridl.ldeo columbia.edu expert link, and then we have here an interface so we can code using Ingrid. And we need to first load the total precipitation variable from the ECMWF model. So we do that like this, source, and then .ecmwf, the institute that is providing the S2S dataset, and then we want the ECMF model, and we want the reforecast set of members of runs, and then the perturb members, and then surface precip and total precipitation. Let's see if I did it right. Sorry. There you go. So now I have my accumulated total precipitation data, and I have for the independent variables, the different grids. I have, for example, the start date S, and I have a coordinate called H date that ranges from all the different years, the lead coordinate in days, etc., etc. So now what I want is to define my start date. I said that I wanted April 16th, 2018, so I need to start with the time UTC, and then 16th April 2018, and it's only one value, so just like that. And now I need to define week 3, so I'm going to do that using my lead coordinate L, and week 3 is written here as these are the beginning and the end of that week. And those are two values. So with S at the end, we want the total accumulated rainfall for that week. So I just need to take the differences between the day 21st and the day 14th. Very good. And then I also want, these are reforecasts, and the ECMWF model provides the last 20 years from the initialization date, which is in this case 2018. So we have 20 years of reforecasts. So basically what we need to do here is to indicate H date, which is my date for those reforecasts. We need to say that I want to start in 1998 to last year 2017, and that's my range. So I have 20 years here. Those are the years that I'm going to use for my calculation of the anomalies. So I still have several members, so I just compute the average on M. M is the coordinate for the ensemble members. And then I'm gonna subtract the climatology. So I need to use basically the same thing that I did here. So I'm gonna just copy the entire thing. I'm gonna DUP is just to have a copy on the stack of the same subsection of the dataset that I just wrote above, and I'm gonna take the average on all the years, age, date, average. So what I actually have here in this line, since I copied the entire thing and now I'm computing the let's say temporal average. So now I just have the climatology, and what I want is to subtract this one and this one. So I just do this, and voila, basically that's it. But I might want to just transform my units to millimeters. So one way to do that, if I want to do that, one way to do that is just to divide by a certain constant that I'm going to define here. I'm going to say that the name is just the water density. Okay. This is a common practice, so I'm just adding it here so we know that we can do it, and we actually make sense to use it in future videos too. So this means that I'm defining a constant, and this is the end of that definition section for that constant, and I have a name and I have the values, even the units. So I'm going to divide by that constant, and I'm going to transform everything to millimeters. So I need to convert. So we click OK, and then we can go to the Views tab, and we select this panel, and we're going to have the anomalies plotted very soon. And okay, there you go, it's coming. And then I computed the long-term average, the climatology, and then I did the subtraction just to have the anomalies. And then I just changed everything to millimeters, so I have like more common units. And I finally can visualize that for the different years. I just kind of like click in each one of those. It might take a while. So now I want just to go back. This is our example for the case of the on-the-fly, the ECMWF model in this case. So remember, from here to here, we have each one of those, let's say, values for each one of the grid boxes. And then in this part, I am actually computing the climatology, and then I'm subtracting, and then I'm transforming to millimeters at the end. So now I want to do the same, but for the fixed reforecasts. And in that case, I'm going to consider the NCEP model. So I will need to modify a little bit this structure, but at the end, it's going to be very similar. We'll need to compute the climatology, then I will need to subtract, and then I might also do the same trick to transform everything to millimeters. So let's just start over here. And for the case of the NCEP, I'm just going to write here NCEP, and then I want again the reforecast, and I want the perturbed members and surface precip and total precipitation. Let's see if I wrote it right. Very good. So now in this case, my independent variables are a little bit different. Note, for example, that the lead is called L1, so that's something important to remember. M is still for members, you know, the coordinate variable for the members, and I still have the S for the start date. So now we can just write. In this case, things are, as I mentioned before, since it's a fixed reforecasting, things are a little bit different. I still need to add my time in UTC, but now I'm going to say that I want all the Aprils. So it's values. So I'm going to select all the initializations for April 16th in all the available years that I have in the NCEP model. And then now I need to choose my lead time, which is in this case L1, and is again 14 to 21, and I have those two values, and as before, but now using L1, I need the differences, and I can also take the average on the different ensemble members, perturbed members that I have. And now I want to compute my climatology, so I just like have a copy of the entire thing, which is that DUP, like duplication, and then now I say, please take an average on all the start dates. And I need to add this subtraction in order to have the anomalies. So again, if I want to have everything in millimeters, I can just have something like this. This is a constant that I said that we'll define a name for it, water density, and that is 998 kilograms per cubic meters. And of the definition of the constant, I want to divide by that constant, and now I can finally go to millimeters. So I did something wrong here. All right, so I found the small mistake there. Very good. And now I have everything I need, and I can actually go to views and then this panel, and I have my anomalies for each one of those years. In the case of NSEP, know that I actually I don't have. I have from 1999 to 2010, so the number of years is different, but I have anyways the equivalent code, and I can also visualize my anomalies as we did before. So if you have any questions, send us an email to help@iri.columbia.edu, and remember that there are other short videos available if you want to keep practicing how to use the IRI Data Library for your S2S experiments. Thank you very much.